We are still solving trigonometric equations by factoring. And the examples that we haven't looked at yet involve splitting the middle. We're going to split the middle factoring. And we've never factored when we had something like a tangent in here. But we can steal something that we use a lot in calculus called U substitution. So what we do is we look over here to the problem and we see that in this problem we have tangents. We have tangent squared theta and we have tangent theta. So what we're going to do is we're going to, off to the side here, we're going to let U represent the tangent of theta. And the only reason that we do that is so that we can factor this equation without using a tangent in there. So we come over here to the problem then, and instead of tangent squared, we're going to write U squared. And instead of tangent, we're going to write another value that represents tangent, which is U. And then we have minus 2 equals 0. We haven't changed the value of the problem, but we've written it in more of a format that we're used to using when we factor. And then we can split the middle. In fact, it's pretty similar. We've got a 1 in front of the U squared, a 1 in front of the U, and 1 times 2 is 2, and the only factors of 2 are 1 and 2. So 1 times 2. If we do 1 minus 2, we will get the negative 1. Splitting the middle. So we've got the U squared and the minus 2. And now it's going to be plus 1U minus 2U. In fact, I'm going to put this minus here in red. But we're going to be grouping. And in our first group, the greatest common factor is U. And we're left with U plus 1. U squared divided by U is U. We had 2 U's, we took 1 out. I put that minus sign in red because that is what's causing some people to struggle with their factoring. We're going to factor out the greatest common factor of 2, and in fact it's really negative 2. And negative 2U divided by negative 2 is U. Negative 2 divided by negative 2 is 1. And in general, what happens is the first, whatever we get in the first parentheses, we should get in the second parentheses. But within our groups, we've got U plus 1 and U minus 2. But we used the U to help us factor. But ultimately what we really need to do is we need to go back and put in what U represents, which is back up here at the top. U is really tangent of theta. So we're going to put tangent of theta plus 1 back into our parentheses, and tangent of theta minus 2. Now we have a trigonometric equation to solve. We're setting each factor equal to 0. Tangent of theta plus 1 equals 0. And tangent of theta minus 2 equals 0. So we're going to subtract 1 from both sides. And let me suggest yet again, and if you don't know the tangent functions, that you memorize at least the first quadrant. Because where does tangent of theta equal 1? Tangent of theta equals 1 at pi over 4. But we're looking at tangent of theta equals negative 1. All students take calculus. So we really want pi over 4 angles where tangent is negative. So we want a pi over 4 angle in the second quadrant because sine is the positive function in the second quadrant. And we want the pi over 4 angle in the fourth quadrant because pi over 4, or cosine, is positive in the fourth quadrant. So the pi over 4 in the second quadrant is 3 pi over 4. The pi over 4 in our fourth quadrant, as I'm lucky enough to be able to scoot this over a little bit, the pi over 4 in the fourth quadrant is 7 pi over 4. And as we think about this here, 3 pi over 4 is here, and 7 pi over 4 is here. And can we connect these two with a straight line, because we're finding the general formula for all of these? And what we see is that yes, even though my line's not very straight, we can connect them. And when we can connect them with a straight line, this is going to be plus pi k. But that's one factor. So let's go over here and look at the second factor. We're going to add 2 to both sides. And we have tangent of theta equals 2. And the question now becomes, is where does an angle have a value of 2 for tangent on the unit circle? And if you're really thinking of the first quadrant, tangent of 0 is 0. Tangent of pi over 6 is radical 3 over 3. Tangent of pi over 4 is 1. Tangent of pi over 3 is square root of 3. Tangent of pi over 2 is undefined. Did I ever say 2 in there? No. We don't have any values on the unit circle where the tangent of theta equals 2. So over here, sometimes what people like to do is they like to write no solution for this part. Sometimes people just like to cross it out. But we don't have any values. We don't have any angles that have a value of 2 for tangent. So again, we still need to be very, very familiar with our functions on the unit circle and their values. So what I'd like to say, we need to know the unit circle forward, and we need to know the unit circle backwards. But as we finish here, let's look at one more with a using a u substitution. In this particular case, we have cosine squared and cosine in our function. So we're going to let u equals cosine of theta. The only reason we do that is to help us factor a little bit easier. So this becomes 2u squared. Instead of writing cosine, we're going to write u. It says cosine squared of theta, so we need to square that u. Minus cosine of theta, which is u, minus 1 equals 0. And we're splitting the middle. We're going to take 2 times 1, which is 2. Familiar values. 1 and 2 are only values that are going to combine. Sorry, the only values that will multiply to be 2. We need to combine to be negative 1. So once again, it looks pretty familiar. It's going to be 1 minus 2. And it doesn't matter the order that you put these in here. 2u squared isn't going to change, and the minus 1 over here isn't going to change. But we can do plus 1u minus 2u. And just for a little bit of difference, some of you are probably doing minus 2u and plus 1u. Because that way the 2's are together and the 1's are together. I don't think that either way is much easier, but this might be a teeny bit simpler than what we did on the front page of the notes. But here's our group. And here's our group. What does make it a bit simpler is that there's a plus in front of our second group. But our greatest common factor in the first group is 2u. And we're left with u minus 1. 2u divided by 2u is 1, and we have to write the 1. Plus, over here, our greatest common factor is a 1. We're left with u minus 1. In general, what we get in the first parentheses, we should be getting in the second. So we've got u minus 1 here, u minus 1 there. It's u minus 1 and 2u plus 1 when we factor. But what we're ultimately trying to solve for is u equals cosine. So let's put the cosine back in here. Cosine of theta minus 1 equals 0. And 2 cosine of theta plus 1 equals 0. So this goes back to our simple trigonometric equations. We're going to add 1 to both sides. We get cosine of theta equals 1. And once again, drawing a little grid might be helpful for you with the quadrantals. But this point right here is 1, 0. And I know I didn't put them all in, and maybe I need to put them in a moment, some more others. But there's 1, 0. And cosine is the x value of the order pair on our unit circle. And what we figure out here is that theta is going to be 0. Well, that's the only one. So if we want to have the general formula for it, since there's only one, we're going to have to add 2 pi k to that. So if we go around once, then it's going to be 2 pi. If we go around twice, we get to 4 pi. If we go around 3 times, we get to 6 pi, and so forth. Over here, on our other factor, let's subtract 1 from both sides. And we get 2 cosine theta equals negative 1. Divide both sides by 2. And we end up with cosine of theta equals negative 1/2. And then many of us are familiar with using our hands. It's really a helpful technique. Where's cosine 1/2? When we fold in our index finger, because we've got one thumb above there, so one finger above, and our index finger represents pi over 3. As I go back to the grid that we were drawing, all students take calculus. We need functions here where cosine's negative, or we need quadrants where cosine's negative. And cosine's negative in the second quadrant because sine is positive there. And cosine's negative in the third quadrant because tangent's positive there. So we need a pi over 3 in the second quadrant, which is 2 pi over 3. We need a pi over 3 in the third quadrant, which is 4 pi over 3. And then we can go back and figure out, are we going to be adding plus pi k, or are we going to be adding plus 2 pi k? Our pi over 3 is here and here, so when we connect, looks like that. Can we connect it with a straight line? No. And because we can't connect it with a straight line, this is going to be 2 pi divided by 3 plus 2 pi k, and 4 pi divided by 3 plus 2 pi k.